Alright, so this video is about Unit 3, Part B, Number 1, Letter D. All these different steps to figure out what problem we're looking at. There we go. Okay, so a little background information. If you have a function and an inverse, so let's say I've got, let's say I have a point 1 comma 4 on my function, then the inverse would also have the corresponding point 4 comma 1. So that's f inverse of x. Okay, because the domain and range switch. If we know what the slope or the derivative at this point, 1 comma 4, let's say that the slope is 3 halves, then the corresponding slope of 4 comma 1 on the inverse would have to have a slope of 2/3. The reason that's true is because they have to be symmetrical with a line y equals x. Okay, so a point on f of x, if it has 3 halves, then the reciprocal will be the slope of the coordinating point on the inverse. Okay, not the opposite reciprocal. They're not perpendicular. They're just reciprocals of each other. So if the original function looked like that, then the inverse has to be symmetrical with the line y equals x, the reciprocals. Okay, so in part D, we know that original point is 1, 6, comma 0. That is on f of x. So that f inverse must have the point 0, comma 1, 6. Okay, we can find the slope at 1, 6, comma 0, just plugging in x and y into our differential equation. Well, it's given to us to be 4 over 2y plus 1 squared. There's actually no input for x. But if you plug in 1, 6, well, that's no x. But if you plug 0 in for y, I get 4 over 1, so I get 4. Okay, so the slope is 4 there. So therefore, we know that the f inverse prime of 0 must be the reciprocal of that, so that is 1/4. All right, hopefully that makes sense.